Now look at how alcohols are prepared. So we had learned in alkyl halides that they can react with aqueous KOH or alcoholic KOH. So if I write down aqueous KOH, just divide the compound into two. So CH3CH2OH, CH3CH2OH plus KCl. Similarly here, Br from here will be lost and OH will replace it. So it will give me a secondary alcohol. Now in tertiary alcohols there is a problem. This is a tertiary halide, there is a problem. Even if I react with aqueous KOH, this undergoes dehydrohalogenation. So if it undergoes dehydrohalogenation, it means that it is going to remove an halogen. It's going to remove a hydrogen from the neighbor. Now this carbon atom contains Br. This carbon atom contains 3 other carbon atoms. All of them are its neighbors. All of them have same number of hydrogen atom. So I can remove from any one of them. So I am removing from here. So I am writing CH3, CCH3 as such. 1, 2, 3 as such. I have removed one hydrogen from here, so there will be a double bond here because I have removed Br also and H also. So valency of carbon has to be satisfied, and so now it will give KBr plus water. KBr from here, H from here and OH from here gives you water. Now with amines, divide the amine into 3 parts and put OH here, N against N and O here. So your product becomes CH3CH2OH plus nitrogen plus water. See here, we have learned alcohols on oxidation give you aldehyde and aldehydes on oxidation give you acids. So alcohol to aldehyde to acid. Opposite will be if I reduce this, aldehydes will change into alcohols, and so I've taken an aldehyde CH3CHO. If the aldehyde is reduced, there are 2 carbon atoms here, so an alcohol containing 2 carbon atoms will be formed. So actually there is a double bond here, so one OH gets attached here, another gets attached here, so this becomes CH3CH2OH. If I am taking a ketone, again I will add one hydrogen here and one here because there is a double bond at this place. So now this becomes CH3, CHOH, CH3, this CH3 there. So now this is a primary alcohol, this becomes a secondary alcohol. So what you need to remember is aldehydes on reduction give you primary alcohol. Ketones on reduction give you secondary alcohol. If I am looking at an acid, it contains 2 carbon atoms, I am here at an acid. Acid will change into an aldehyde, aldehyde into an alcohol. So directly also I can write down there are 2 carbon atoms here. So I will say an alcohol containing 2 carbon atoms is formed. This is an ester. Ester contains COO group in the center. Ester is also a compound of acid. So I am at acid, it will change into an aldehyde, into an alcohol. So now this ester breaks into 2 parts. That is 2 carbon atoms are this side and 1 carbon atom on this side. After oxygen, chain of carbon atom has stopped. So there are 2 carbon atoms here. So alcohol containing 2 carbon atoms. Then there is only 1 carbon atom on this side, so 1 carbon atom alcohol on this side. Supposing I had taken a compound CH3COOCH2CH3. So I would have reduced it into 2 carbon atoms here, alcohol containing 2 carbon atoms, again alcohol containing 2 carbon atoms. So you will check how many carbon atoms are present. Accordingly, you will make the alcohol.